Hello Algebra 2, and today we're going to talk about 2.2, slope and rate of change. First, let's remind ourselves the definition of slope. So slope is the ratio of the vertical change to the horizontal change. So vertically, we're looking at the y-axis. So that would be the difference, this is the difference in the y's, over horizontal change would be your x-axis, so it would be the change in the x's. The second thing I have written here, these are read delta, make sure I can spell delta here, delta x, so it would be delta y over delta x, and delta means change in. So you can read it delta y, or you can read it change in y. And lastly but not least, reminding ourselves that it is the rise over the run. And so sometimes that very basic definition there, it's the rise over the run, helps us to solve the problem. And remember too, the slope is telling you the steepness of a line. So if I have a line here, right, and maybe I can find 2 points on my line, and so then this value here would be the change in y, and this value here would be the change in x, and that is the same as my rise over my run. So can we find the slope of the line that passes through 2 points? We sure can. Okay, so we're going to use our formula. Y2 minus y1 over x2 minus x1, and I would say if you do not have your formula memorized, I'd write it down on every single problem until you have it memorized. Now it does not matter which point is point 1 and which point is point 2 as long as you're consistent. So if this is point 1, it has to be point 1 for x and y, or if this is point 1, it has to be point 1 for x and y. So whatever coordinate you pull y from on the top, you have to use that same coordinate, that same ordered pair to pull y from on the bottom. So let's just make this be x1, y1 and x2, y2, just kind of a conventional naming there. So y2 is going to be negative 1 minus, because that is in my formula there, y1 is a negative 4. Over x2, which is 3, minus, again, because it's in my formula, x1 is a negative 2. So yes, you can change the minus and negatives to plus a positive, or chop chop, or whatever you do there. Negative 1 plus 4 is 3, and 3 plus 2 is 5. So the slope between those 2 points is 3/5. So it'd be up 3 and over 5 to get from one point to the other. There are 4 different types of slopes we can have. So the first type of slope is going to be a slope that rises as you go to the right, and this slope is positive. So the example we just did had a positive slope. You can have slopes that fall going left to right. Okay, these slopes are negative. Now notice they can have the same steepness. So just a little side here, 3/5 and negative 3/5 have the same steepness. I mean, it'd be the same as saying the slope on the front of your house and the slope on the back of your house. They can have the same slope, they're just slanted different ways. Okay. Next up, if you have a horizontal line that has 0 slope. And the final one, if you have a vertical line that has an undefined slope. Undefined slope. One thing to realize, first of all, there is no slope. No slope is not an option. You're either 0 slope or you're undefined slope. The other thing is, if you haven't had me before, my way of remembering which one is 0 and which one is undefined, I can make a z out of the 0 slope, so it tells me I got 0, and I can make a u out of the undefined slope, so that one tells me it's undefined. Just if you need a little trick to help you remember. So let's do a quick example here. Find the slope and then tell whether it rises, falls, is horizontal or vertical. So essentially, if it has positive slope, negative slope, 0 slope, or undefined slope. So we're going to do the same way we did it before using our slope formula. And still, if you haven't remembered your formula, I would write it out. This is the slope formula. Okay. Y2, I'm going to make be 5. So minus y1 would be 3 over x2. So if I picked 5 first for my y's, I have to pick 1 first for my x's. Minus a negative 2. That is 2 over 3, which is positive. So this one rises. Okay, so find the slope and tell whether it rises. The other one, again, I'm going to use my slope formula. Okay, and so this one, let's say I pick this y as my first y. So if I do negative 2 minus negative 2, then I'm going to have to pick 1 as my first x, 1 minus 3. So that works out to be 0 divided by negative 2, which is 0, right? Remember, it is okay to have 0 on top. You do need to simplify it to be 0. So 0 would mean that it is horizontal. There we go. Now we have an example of tell whether which line is steeper. So what I was getting to back on the types of slope page is that the sign doesn't matter. So a negative slope could be steeper or the positive slope could be steeper. The sign doesn't matter. It's just the bigger number is steeper. Okay? So what we need to do is we need to find the slope of both. So I'm going to do a subscript here, and this is going to be the slope of line 1. All right, using my same slope formula here. And so this is going to be, if we do 2 minus a negative 4 over 5 minus 1. This is going to be 6 over 4, which is 3/2, because you always reduce your slope. Never change slope to a mixed number. Never, ever, ever change a slope to a mixed number. You leave it just like that. And the slope of line 2, okay, same formula. I'm going to write it out every time. Is going to be negative 2 minus a negative 5 over 1 minus a negative 2. Change my signs. This is going to be 3 over 3, which is 1. Which one is steeper? 3/2 is greater than 1, so line 1 is steeper. We're going to end up today talking about parallel and perpendicular lines. And for lines to be parallel, they have to have the exact same slope. Okay, and that's what keeps them from touching, is that their rate of changes are exactly the same. Okay, and so by the way, when I ask you, what do you know about parallel lines, I don't want to know they don't touch. That's a more of a geometry definition. I want to know they have the same slope. Algebraically speaking, they have the same slope. Okay? So for perpendicular lines, okay, and you probably know from geometry, perpendicular lines are lines that cross at right angles. Okay, that's your geometry definition. So the actual definition is two lines whose slopes have a product of -1. So the slopes have a product of -1. So it'd be like negative 3/2 and 2/3. If those were your two slopes, you multiply together to be -6 over 6, which is -1. So those would represent two lines that are perpendicular. A little bit faster of a way to say, what do you know about the slopes of perpendicular lines, is that they have opposite reciprocal slopes. So opposite is in sign, so they're going to have opposite signs. So one's positive, one's negative. And then reciprocal means that you flip that fraction. So you're going to flip that fraction. So if you notice here, between negative 3/2, so negative to positive 2/3, so opposite sign, and then my fractions are reciprocal, so I've taken 3/2 and I flipped it to be 2/3. So these are opposite reciprocals of each other. Okay. So let's look at this in an example. So tell whether these lines are parallel, perpendicular, or neither. Well, to do that, you need to find their slopes. So again, to the slope of line 1, by the way, a dear friend of mine once said, a way to remember the formula here is that the yams and the yogurt are on the picnic table. If you look, right there, the picnic tables with the X's on the ends. So the yams and the yogurt are on the picnic table, if that helps you remember. Alright, so let's do here. -2 minus a -2 over 3 minus 1. This is going to be 0 over 2, which is 0. Okay. And the slope of my other line, let's see here, y2 minus y1 over x2 minus x1. It's going to be 4 minus 4 over 0 minus a -5. Which is going to be 0 over 5, which is 0. Those slopes are exactly the same, so these two lines are parallel. Alright, that's all I got for you today. We will do some more examples in class, but let me know if you have any questions before then. Have a good day.